Hello everyone. Hello everyone. Good morning. So today we are back again here for subject physics. Yesterday we studied both types of semiconductors, intrinsic in detail, also extrinsic in detail. In intrinsic, we get equal number of holes and electrons, equal number of charge carriers, and conduction is due to both types of charge carriers. In extrinsic semiconductor, if you consider n type, majority charge carriers are electrons which are obtained by donor impurity added to pure semiconductor. Similarly, in p-type, majority charge carriers are holes which are obtained by adding acceptor impurity to pure semiconductor. When you think of n-type semiconductor crystal, or if you consider p-type semiconductor crystal as a whole, both are electrically neutral. We say, I am not started yet. I am just revising what we learned till now. So here both are electrically neutral. We say these extra electrons available for conduction. Otherwise, when donor impurity is added or acceptor impurity is added, atoms of donor impurities or acceptor impurities are neutral. They possess equal number of proton and electrons. So electrically, the crystal as a whole of individually n-type or p-type is electrically neutral. Only we say they are available for conduction. Here electrons, and in p-type we get holes as a charge carrier. So electrically each crystal is neutral. So this is about n-type and p-type extrinsic semiconductors. We will switch over further to study the effect produced if n-type and p-type are fused together, are combined together, joined together. What happens, that we will study today. Now I will announce the page. It is on page 249. Open page 249 from the textbook. We are starting with article 14.6. And earlier I discussed the point which is on page number 248, part C, charge neutrality of extrinsic semiconductors. So p-type, n-type as a crystal, they are electrically neutral. They don't have any polarity. So remember this point well. With the basic knowledge of these two, we'll proceed further to study the effect produced when both are connected together, are joined together or fused together. Suppose p-type is connected with n-type or joined with n-type. Then in the contact region, the junction is created. And this junction we call as PN junction. Immediately after the formation of this junction, what happens? N region is rich in electrons, P region is rich in holes. So immediately after formation of junction, electrons from N region cross the junction and recombine with holes in P region immediately. So what happens that time? You get migration of charge carriers through this junction when these two regions are joined. At the joint contact, you get junction, and whenever junction is formed, immediately charge carriers from both region diffuse. They cross the junction and go into the other side, go into the other type. So electrons from N region diffuse, migrate, cross the junction and enter in P region. In P region, there is lack of electrons, that is formation of holes is already there. So they recombine with these holes. Similarly, here electrons are transferred and automatically at the position of electron the hole is created. Absence of electron gives rise to formation of hole. So holes move towards negative side, towards N type, and electrons move towards P type. So this is called diffusion of charges. So charges get diffused. So his electrons are absent now. The electrons which are available are moving in P region. And what happens that time? Due to lack of electrons from N region to P region, this donor, because in N type we are added donor atoms which donate the electron. So one electron from each atom gets migrated, and hence near the region the formation of donor positive ions take place. This is the case when immediately the junction is formed. Similarly here, these are the holes. These electrons recombine with hole, and when recombines with holes, here the earlier it was electrically neutral, but this time gaining the electron, each acceptor atom becomes ion, and addition of negative charges, there is formation of negative acceptor ions. Initially, when there was no flow, each acceptor atom or each donor atom is electrically neutral. Now there is actual diffusion of charges. So each atom lacks one electron and hence it acquires positive charge. So donor atom which was electrically neutral now has the form of positive ion. So in N-type region near the junction, you get accumulation of positive donor ions, and in P-type region near the junction, we get accumulation of acceptor negative ions, and hence you get accumulation of ions on both sides of the junction formed. This creates potential difference. This is positive. The total voltage developed on P side will be negative. So you get development of potential difference across the junction, and this results in further flow of electrons anymore. So when these ions are formed, potential difference or electric field automatically gets developed within this PN junction material. It has its own potential. Electric field is created within this PN junction, and the electric field created is positive to N side and is negative to P side. So electric field generated we can represent it with like this. This is ionic level. So this is positive on N side and this is negative on P side. Otherwise here you are get accumulation of charges. what happens when this electric field is formed? Any further flow of electron or hole from other side after crossing the junction get resisted. We don't get any further migration, any further diffusion of charges even are available readily in both these regions, and hence this potential is called barrier potential. It controls or it doesn't allow to cross the next electrons or holes to get migrated in opposite direction, and hence this is called barrier potential. It resists the flow of charges. So this value of barrier potential is different. The thickness of this is accumulation on both sides. N type you get positive ions, P type you are getting negative ions. So within this region we don't get any free charge available. Neither hole is present nor electron free is available for conduction. It is depleted from free charge carriers, and hence this is called depletion layer or depletion region. So we are taking the account of few more terms. 1 minute. If there is any disturbance, network issue, please stay tuned. Don't leave and comment in chat box. Many times we are facing internet issue. So I am just checking whether is not any problem for that. So wait for a while. And if it is happening, then be sure you don't leave the meeting, because there is connectivity problem every day, sometimes smooth going or sometimes many short disturbance. So with considering all these technical issues, you please remain tuned for each and every class, for each and every subject. This is the appeal from all of our teachers. Do stay tuned. So this is the announcement I just wanted to do earlier, but still. So we are talking about, now we have moved further from page number 249 to 250. I am talking about depletion region on page 250. So depletion means what? Depleted charges are not present, not observed within this region. The region is depleted of free charges, and within depleted region we get accumulation of ions which produce barrier potential near the junction, electric field within the piece near the junction. The barrier depletion layer is width, thickness, as well as electric potential, barrier potential. Both can be controlled. We can control the thickness or width of barrier depletion region, as well as we can adjust set the value for barrier potential by considering suitable doping. Remember all these points well. So these two can be controlled externally while prepare formation of this PN junction. So what happens when no external electric field is applied across this crystal? Due to barrier potential, further diffusion of charges from both regions into both regions crossing the junction is not possible, and hence at normal condition we don't get any current further. Once you get diffusion of charges, once depletion layer is prepared, current is not observed through such piece, through such PN junction. Remember these points well. And the junction is said to be in unbiased condition. So now we will proceed further to study the characteristics of this PN junction. The PN junction, once I have not changed any setting, so even you are not observing the screen clearly, I am trying my level best. Also open the books and along with the teaching, go through the textbook also. I have already announced page number 250. So we'll proceed further. So at normal condition, the PN junction is always in unbiased mode. Formation of depletion region, formation of electric field which gives you barrier potential across the junction is its unbiased mode. So still if you want to pass current through it, even if, when it is unbiased, it doesn't carry any current. But if you want to pass current through it, then these electrons and holes available should gain energy, and after gaining energy they will be able to cross this barrier potential, and then they are able to cross the junction and they can circulate in the external circuit. So to have current through it, the PN junction is needed to bias. We have to bias it to observe current through it. We have to provide external electric energy so that we can observe flow of charges through it. The biasing is of two types. One is called forward bias mode and the other is called reverse bias mode. Forward biased and the other is reverse bias. What is happening in forward bias mode? What we do, if you connect P type to positive terminal of external electric source and N type to negative terminal of external electric source, when the value of external electric source is small, then energy received by this electron in N region is not sufficient to overcome this barrier potential, because this energy provided is unable to overcome this barrier potential. So even you apply electric field externally, for certain below certain value of applied field, we never observe electric current. Go on increasing this value of E. You take variable source whose potential can be varied. Then this negative repulsion energy acquired by electrons, if is sufficient to cross this barrier potential, electrons move in P region and will be driven in external circuit. That time you observe electron motion and hence conventional current will be from P side to N side. So in forward biased mode, large current can pass through this junction when P connected to positive and N connected to negative, but only after beyond certain value of E, till if E is very small, not considerable, with value of barrier potential even is made on, you don't observe initially the current, but once it overcomes barrier potential with at after certain value you observe current, and this junction behaves as a closed switch. The other way is reverse biasing. In reverse biased mode, P is connected to negative terminal and N is connected to positive terminal. So what happens? Electrons present in N region get attracted toward positive and they are moved away from the junction. Similarly, holes present in P region, which are positive charge carriers, get attracted towards negative terminal of external source and they also move away from this junction. And through the junction, you don't get any current or a little current due to thermal agitation. So in reverse bias, the current in reverse bias or reverse bias current has very small magnitude. If you go on increasing this value of external potential difference, then it is observed if you plot the graph. This is current I for voltage V. For forward bias, initially no current and after certain value the current increases rapidly. Similarly, in reverse biased means this is positive side of V. Now you are making negative side of V. So reverse bias. No current. The current magnitude of current is very low. But when certain V is achieved, this depletion layer gets broken down and it becomes useless. That is called breakdown of PN junction. And after breakdown, the PN junction is damaged. So this is called breakdown voltage. This is reverse bias current and this is breakdown current. So these are called IV characteristics in forward bias and in reverse bias. So in reverse bias, no current, almost no current, and when is used in reverse bias mode, PN junction behaves as open switch. जो हम लोग बटन्स ऑन ऑफ के लिए यूज करते हैं ना, एनी अप्लायंस, फैन, ट्यूब, वो दो प्लग कीज होते हैं. Instead, you can use these electronic keys. Electronic means what? Made up of semiconducting materials. So this is the use of PN junction. This is not only one use, but it has number of peculiar properties and very interesting to study these properties and is fundamental of electronics branch. इलेक्ट्रॉनिक्स डिवाइसेस जो डिजाइन किए जाते हैं उनका फंडामेंटल है पीएन जंक्शन. इट्स वेरी इंटरेस्टिंग टू स्टडी द बिहेवियर of this PN junction. When PN junction has metallic connections, means it can be used in any electronic circuit, in external electronic circuit, then it should be provided with connectors so that these connectors you can use in other electronic circuit. So these are metallic collectors. So PN junction with metallic collectors provided is called junction diode. So I have switched over to point number 14.7 on page 251. आप लोग 251 पेज नंबर ओपन करो. उसमें डायग्राम 14.19 है जो मैंने बोली थी पहले ही. फॉरवर्ड बायसिंग and other is reverse biasing. If current is very large, then this junction diode will damage, and to protect it, we always one resistance is connected in its series. So voltage division takes place and the voltage across diode can be controlled so that it will not get damaged. So the diagrams are given. डिप्लेशन रीजन में जो इन जगह है जंक्शन के राइट में, यू हैव टू शो पॉजिटिव आयन, you have to show negative ion accumulation in P region because acceptor acceptor impurities form P region and acceptor यानी कि उनके पास एक होल हमेशा रहता है, ट्राइवैलेंट है ना वो थर्ड ग्रुप से. तो once the electron is recombining with the corresponding hole, that atom which was electrically neutral will acquire extra negative charge. So in p type you get negative acceptor ions, and on n type you will get positive donor ions. So this is depletion region. So when such is used in electronic circuits or any electric circuits, the name is junction diode. Its electric symbol is one triangle which is filled up, not hollow, and one line. This arrow gives you the direction of current. Triangle P side and the line is negative. This is positive, negative. And arrow gives you the direction of current when it is on. That is when is operated in forward biased region. So with this basic information of PN junction, with knowing its biasing, tomorrow we'll proceed further to study the use of PN junction diode. If this junction is provided with metallic connectors, you can use it in any external circuit, and such junction is called junction diode or simply diode. So tomorrow we will start with PN junction diode. Thanking you all to be present for the meeting. I will post this video. Carefully watch it and derive your own notes. I am giving you the question bank for the of this chapter by Sunday. So thanking you all. I am winding up and I am closing the meeting for all. Thank you.